Alright, I have an interesting integral to share with you guys today. Sorry if my hair is a little messy, it is what it is. But the integral is the indefinite integral of sine squared of x over cosine of the fourth of x dx. Okay, and so now I'm just going to be using some trig identities, and I'm going to rewrite this as the integral of sine squared of x over cosine squared of x times 1 over cosine squared of x dx. Again, I didn't do any trig identities yet. I'm just splitting this off into two separate factors so that I can then apply some trig identities. So I know that this will then be, we know that sine of x over cosine of x is going to be tangent of x, and so this will just be tangent of x. And then we'll have to square that because, again, sine squared of x over cosine squared of x is just sine of x over cosine of x squared, and then that's just going to be tangent of x squared, which then we can write as tan squared of x. And so let me move this light down a little bit, and so we have tan squared of x, and then that times then secant squared of x dx. And so now we need to think about how we can go from here. So you may be stuck for a moment, and that's fine, but we need to think about the relationship between secant of x and tangent of x, specifically with their derivatives. And so if we look at tangent of x here, we ignore the squared part. If we look at tangent of x, we know that the derivative of tangent of x is secant squared of x. So if we then do a u substitution here, if we let u equal to tangent of x, okay, this is the hardest part of the problem. You have to kind of recognize this pattern or this relationship. And so again, u equals to tangent of x, and so then du will just be secant squared of x dx. And so from here we can just do some substitution. So then we'll get the integral of tangent of x, tan squared of x. Again, u is tangent of x. This will be u squared, and then that times secant squared of x, or again, what we have to solve for dx. Sorry, dx is just du over secant squared of x. And so then we'll have secant squared of x times our dx. We'll have secant squared of x, and then that times our dx, which is du over secant squared of x, and then ultimately we get what we want with the u substitution, and that's that things will cancel. And so then we see here that the secant squared of x will cancel, and then we just get a simple integral of u squared du. And so in order to do this, we just use power rule. So then it'll just be u cubed over 3 and then plus our constant of integration because we're dealing with an indefinite integral. And so then what is u? U is just tangent of x, and so then we'll then just get for our answer, this is just going to be tangent cubed of x over 3, and then can't forget our constant of integration. So hopefully you found this integral quite interesting. It's not too difficult. You just got to use some trig identities and kind of see what you can get with that, and relationships with derivatives and stuff like that. So again, just identifying these patterns and doing more practice, then you can get better and better at these problems.